Good day class. We will discussing today about Introduction to Java Programming. What is Java programming language? Java programming language is a platform-independent language, which means there is no limitation to any particular hardware or operating system. It provides users the facility to write once, run anywhere. Many operating systems such as Sun Solaris, Red Hat, Windows that support Java. Java is a popular programming language, created in May 20, 1995. It is owned by Oracle, and more than 3 billion devices run Java. James Gosling and Sun Microsystems. Sun Microsystems funded an internal research project Green to investigate this opportunity. Result: a programming language called Oak. Problem: there was already a programming language called Oak. The Green team met at a local coffee shop to come up with another name. What is Java programming language? The popularity of the Internet resulted in Sun's refocusing of Java on computers. Prior to the advent of Java, web pages allowed you to download only text and images. Java-enabled web browsers allowed for the downloading of programs, applets. Java is used for mobile applications, desktop applications, web applications, web servers and application servers, games, database connection. Why use Java? Java works on different platforms: Windows, Mac, Linux, Raspberry Pi, etc. It is one of the most popular programming language in the world. It is easy to learn and simple to use. It is open source and free. It is secure, fast and powerful. It has a huge community support, tens of millions of developers. Compiled programs with different operating systems. Where computer program can be written in any applications and can be compiled in Windows, Mac, or Unix operating systems and can also be executed also in Windows, Mac OS or Unix operating systems. A high-level view of translating/executing Java programs. Stage 1, compilation. Whereas compiling allows the computer to run and understand the program without the need of the programming software used to create it. First, creating a Java program and save as any file name with file type .java. Then you must compile the Java program using the Java compiler in order to check the program if there is an error or not. If there is no error, the compiler will generate a file type .class in order the program can be executed. A high-level view of translating/executing Java programs. Stage 2. Interpreting and executing the bytecode. A point to keep in mind is that bytecodes are non-runnable codes and rely on the availability of an interpreter to execute, and thus the JVM comes into play. Bytecode in Java is the reason Java is platform independent. As soon as a Java program is compiled, bytecode is generated. To be more precise, a Java bytecode is the machine code in the form of a .class file. Based from the program created and was saved as any file name with file type .java. An interpreter, on the other hand, just translates one instruction at a time, and then executes that instruction immediately. Java uses a compiler to translate Java programs into Java bytecode, which is a machine language for the imaginary Java virtual machine in which it can be compatible to Unix, Windows, or Apple operating systems. Characteristics of Java. Java is simple. The Java programming language is easy to learn. Java code is easy to read and write. Java language is simple than the previous languages such as C and C++. Java eliminates the pointers concept which is earlier present in C and C++. Java also has a properties example automatic allocation of memory and garbage collection, whereas in C or C++ the garbage collection and allocation of memory will be done by the programmer, which is a complex task. If you understand the basic concept of OOP Java, it would be easy to master. Java is object-oriented. In Java, everything is an object. Java can be easily extended since it is based on the object model. All the programming languages apart from the C++ are procedural languages which are paradigm of procedures. Java programming language is object-oriented because Java uses the concept of the object. In Java everything will depend on objects. Example is creating the objects and making objects to work together. The overall functionality of the high-level program will depends on the objects. Because Java is object-oriented program, it provides great range of reusability, modularity, and flexibility. Java is distributed. Java is designed for the distributed environment of the Internet. Java uses the Hypertext Transfer Protocol or HTTP and File Transfer Protocol or FTP, which are Internet protocols, in order to have access the files over the network. So by using this libraries which are in Java can easily make file transfers over the network which is connected to Internet. Java is interpreted. Java bytecode is translated on the fly to native machine instructions and is not stored anywhere. The development process is more rapid and analytical since the linking is an incremental and lightweight process. In order to run the Java programs we need interpreter. When the Java programs are compiled it produces the bytecode, which is machine understandable language. The bytecode which is produced after the compilation is machine independent, so that it can run on any system using Java interpreter. Most of the compilers will convert the high-level language instructions to the low-level machine understandable language as machine can't understand the high-level instruction. The machine code can only be executed on that compiled native machine. For example, a source code is compiled on Windows platform, the executable file produced after can't be executed on other platforms apart from the Windows. The source code is compiled once and the executable bytecode can be run on any platform using Java interpreter. The main functionality of the interpreter is, it converts the bytecode to the machine language of the target machine. Java is robust. Java makes an effort to eliminate error-prone situations by emphasizing mainly on compile time error checking and runtime checking. Java programming is more reliable. At the time of the execution time Java shows all the errors. In Java bad and error-prone language constructs are eliminated. Java eliminated the concepts such as pointers. Due to this there is no corruption of data and overwriting the memory locations. In the same way Java supports the exception handling, which makes Java more reliable and robust. Java forces the programmer to write the code for the exceptions, which may occur during the execution of the program. So that program can be terminated successfully, without any error stopping the execution flow of the program. Java is secure. With Java Secure feature it enables to develop virus-free, tamper-free systems. Authentication techniques are based on public key encryption. Java also provides the lot of security. Security is important over the network because the computer will be attacked by the external program. Java provides the security that, it encounters the applets for the untrusted sources. Java is architecture neutral. Java compiler generates an architecture-neutral object file format, which makes the compiled code executable on many processors, with the presence of Java runtime system. Java is an interpreted language, which enables Java as an architectural neutral. Example is platform independent. We can write the program once and it can be executed on any platform with the help of the Java Virtual Machine or JVM. The Java Virtual Machine can be embedded on the operating system or on web browser. Once the part of the Java code is loaded into the machine, it is verified. Bytecode verification play a major role, as it check all the code generated by the compiler will not corrupt the machine on which the code is loaded. At the end of the compilation, bytecode verification will be done, in order to make sure that the code is accurate and correct. So the bytecode verification is the integral to the compilation and execution. Due to the property of architectural neutral had by Java, it is portable. The program once written can be run on any platform without recompilation. Java is portable. Being architecture neutral and having no implementation dependent aspects of the specification makes Java portable. The compiler in Java is written in ANSI C with a clean portability boundary. In Java, the size of the primitive data types is machine independent, which were dependent in the case of C/C++. So, these provisions make Java programs portable among different platforms such as Windows, Unix, Solaris, and Mac. Moreover, any changes and updates made in operating systems, processors, and system resources will not enforce any changes in Java programs. Java's performance. With the use of just-in-time compilers, Java enables high performance. The Java compiler is designed for performance. Java code is compiled into bytecode and then compiled by the Java compiler. It is fed to the JVM or Java Virtual Machine, before it's converted to machine-level code. Java is multi-threaded. With Java's multi-threaded feature, it is possible to write programs that can perform many tasks simultaneously. This design feature allows the developers to construct interactive applications that can run smoothly. It is defined as the program's ability to perform several tasks, or functions simultaneously. The multithreading property is embedded in the Java program. Using the Java programs, we can perform the several tasks simultaneously without calling any procedures of the operating system, which is done by the other programming languages in order to perform the multi-threading. Java is dynamic. Java is considered to be more dynamic than C or C++ since it is designed to adapt to an evolving environment. Java programs can carry an extensive amount of runtime information that can be used to verify and resolve accesses to objects at runtime. Where is Java being used? For several years, Java has been the language of choice of naive and experienced programmers, alike. Some of the most important uses of Java are creating Android applications, though there is a variety of JVM usage and packaging methods for the distribution of Android apps, the code written is basically Java. Even the latest Android app maker Kotlin programming language is inspired by Java. Google's Android API is used predominantly for making apps for the Android platform. Designing web applications. Another popular use of Java is for designing web applications. In addition to private organizations like Google, government facilities, healthcare institutions, educational bodies, and even defense departments rely on Java for building important web applications. Scientific applications. Java is also used for making scientific applications a reality. It is preferred over C++, which is also used for the same purpose because it flaunts better high-level concurrency tools in addition to being maintainable, portable, and safe. Software tools. Java is a big part of the software industry. It has been used to fuel open source and commercial projects alike. Eclipse, IntelliJ IDEA, and NetBeans IDE are some of the best IDEs to create Java applications, and even they are developed using Java. Java syntax. Java is case-sensitive. The all capital letters of my class and all small letters of my class has different meaning. The main method is required, and you will see it in every Java program. Inside the main method, we can use the println method to print a line of text to the screen. In this program, it simply prints "Hello Engineer" to the screen. Public means accessible from outside. Class keyword creates a type, and prog1 is the class name. Public static void main, string args, are called main method, which is the starting point of a Java program. The main is the method name, string is an array of strings, and args is a variable name. System.out.println, hello engineer, this statement prints hello engineer. To the screen. Java comments. Comments can be used to explain Java code, and to make it more readable. It can also be used to prevent execution when testing alternative code. Single-line comments start with 2 forward slashes //. Example. // this is a comment. System.out.println, hello world. System.out.println, hello world, // this is a comment. Java multi-line comments. Multi-line comments start with /* and ends with */. Example. /*, the code below will print the words hello world to the screen, and it is amazing */. System.out.println, hello world. Java variables. Variables are containers for storing data values. In Java, there are different types of variables. For example, string stores text, such as hello. String values are surrounded by double quotes. Int stores integers, whole numbers, without decimals, such as 123 or -123. Float stores floating point numbers, with decimals, such as 19.99 or -19.99. Char stores single characters, such as a or b. Char values are surrounded by single quotes. Boolean stores values with 2 states, true or false. Declaring, creating, variables. To create a variable, you must specify the type and assign it a value. Type variable equals value. To create a variable that should store text, create a variable called name of type string and assign it the value engineering. String name equals engineering. System.out.println, course. To create a variable that should store a number, look at the following example. Create a variable called number of type int and assign it the value 75. Int number equals 75. System.out.print, number. It can also declare a variable without assigning the value, and assign the value later. Int number. Number equals 75. System.out.print, number. Demonstration of how to declare variables of other types. Int my number equals 3. Float my float number equals 3.1415. Char my letter equals d. Boolean my bool equals true. String my text equals hello. Primitive data types. A primitive data type specifies the size and type of variable values, and it has no additional methods. Represent numbers, characters, Boolean values. Integers, byte, short, int, and long. Real numbers, float and double. Characters, char. Primitive data types. The Java programming language is statically typed, which means that all variables must first be declared before they can be used. This involves stating the variable's type and name, as you've already seen. Doing so tells your program that a field named gear exists, holds numerical data, and has an initial value of 1. A variable's data type determines the values it may contain, plus the operations that may be performed on it. In addition to int, the Java programming language supports 7 other primitive data types. A primitive type is predefined by the language and is named by a reserved keyword. Primitive values do not share state with other primitive values. The 8 primitive data types supported by the Java programming language are: byte. The byte data type is an 8-bit signed 2's complement integer. It has a minimum value of -128 and a maximum value of 127, inclusive. The byte data type can be useful for saving memory in large arrays, where the memory savings actually matters. They can also be used in place of int where their limits help to clarify your code. The fact that a variable's range is limited can serve as a form of documentation. Short. The short data type is a 16-bit signed 2's complement integer. It has a minimum value of -32,768 and a maximum value of 32,767, inclusive. As with byte, the same guidelines apply. You can use a short to save memory in large arrays, in situations where the memory savings actually matters. Int. By default, the int data type is a 32-bit signed 2's complement integer, which has a minimum value of -231 and a maximum value of 231 to 1. In Java SE8 and later, you can use the int data type to represent an unsigned 32-bit integer, which has a minimum value of 0 and a maximum value of 232 to 1. Use the integer class to use int data type as an unsigned integer. See the section The Number Classes for more information. Static methods like compare unsigned, divide unsigned, etc. have been added to the integer class to support the arithmetic operations for unsigned integers. Long. The long data type is a 64-bit 2's complement integer. The signed long has a minimum value of -263 and a maximum value of 263 to 1. In Java SE8 and later, you can use the long data type to represent an unsigned 64-bit long, which has a minimum value of 0 and a maximum value of 264 to 1. Use this data type when you need a range of values wider than those provided by int. The long class also contains methods like compare unsigned, divide unsigned, etc. to support arithmetic operations for unsigned long. Float. The float data type is a single precision 32-bit IEEE 754 floating point. Its range of values is beyond the scope of this discussion, but is specified in the floating point types, formats, and values section of the Java language specification. As with the recommendations for byte and short, use a float, instead of double, if you need to save memory in large arrays of floating point numbers. This data type should never be used for precise values, such as currency. For that, you will need to use the java.math.bigdecimal class instead. Numbers and strings covers bigdecimal and other useful classes provided by the Java platform. Double. The double data type is a double precision 64-bit IEEE 754 floating point. Its range of values is beyond the scope of this discussion, but is specified in the floating point types, formats, and values section of the Java language specification. For decimal values, this data type is generally the default choice. As mentioned above, this data type should never be used for precise values, such as currency. Boolean. The Boolean data type has only two possible values, true and false. Use this data type for simple flags that track true/false conditions. This data type represents one bit of information, but its size isn't something that's precisely defined. Char. The char data type is a single 16-bit Unicode character. It has a minimum value of \U0000 or 0, and a maximum value of \UF or 65,535 inclusive. Numbers. Primitive number types are divided into two groups. Integer type stores whole numbers, positive or negative, such as 123 or -456, without decimals. Valid types are byte, short, int, and long. Floating point types represents numbers with a fractional part, containing one or more decimals. There are two types, float and double. Non-primitive data types. A string in Java is actually a non-primitive data type, because it refers to an object. The string object has methods that is used to perform certain operations on strings. Non-primitive data types are called reference types because they refer to objects. Examples of non-primitive types are strings, arrays, classes, interface. The main difference between primitive and non-primitive data types are: primitive types are predefined, already defined, in Java. Non-primitive types are created by the programmer and is not defined by Java, except for string. Non-primitive types can be used to call methods to perform certain operations, while primitive types cannot. A primitive type has always a value, while non-primitive types can be null. A primitive type starts with a lowercase letter, while non-primitive type starts with an uppercase letter. The size of a primitive type depends on the data type, while non-primitive types have all the same size. Java operators. Operators are used to perform operations on variables and values. The value is called an operand, while the operation, to be performed between the two operands, is defined by an operator. Java divides the operators into the following groups: arithmetic operators, assignment operators, comparison operators, logical operators, bitwise operators. Java defines several bitwise operators, which can be applied to the integer types, long, int, short, char, and byte. Bitwise operator works on bits and performs bit-by-bit operation. Arithmetic operators. Arithmetic operators are used in mathematical expressions in the same way that they are used in algebra. The arithmetic operators are addition, subtraction, multiplication, division, modulus, increment, and decrement. Java assignment operators. Assignment operators are used to assign values to variables. The assignment operator equals to assign the value 10 to a variable called x. Example: int x equals 10. Assignment operators. Following are the assignment operators supported by Java language: simple assignment operator, add and assignment operator, subtract and assignment operator, multiply and assignment operator, divide and assignment operator, modulus and assignment operator, left shift and assignment operator, right shift and assignment operator, bitwise and assignment operator, bitwise exclusive OR and assignment operator, and bitwise inclusive OR and assignment operator. Java comparison operators. There are following comparison operators supported by Java language: equal to, not equal to, greater than, less than, greater than, or equal to, less than or equal to. Java logical operators. The following table lists the logical operators: logical AND, logical OR, logical NOT. Java strings. Strings are used for storing text. A string variable contains a collection of characters surrounded by double quotes. Example: string greeting equals I love engineering. String length. A string in Java is actually an object, which contain methods that can perform certain operations on strings. For example, the length of a string can be found with the length method. Example: string text equals I love engineering. System.out.println, the length of the text string is plus text.length. String to upper and to lower. Example: string text equals hello world. System.out.println, text.to uppercase, / the output of to uppercase is all capital letter hello world. System.out.println, text.to lowercase, / the outputs of to lowercase is all lower letter hello world. Finding a string in a string. The indexOf method returns the index, the position, of the first occurrence of a specified text in a string, including with space. Example: string text equals please locate where locate occurs. System.out.println, text.indexOf, locate, / the outputs is 7. String concatenation. The plus operator can be used between strings to add them together to make a new string. This is called concatenation. Example: string first name equals Ronald. String last name equals John. System.out.println, first name plus last name. Escape sequences in Java. A character preceded by a backslash, is an escape sequence and has a special meaning to the compiler. The following table shows the Java escape sequences. \n inserts a new line in the text at this point. \r inserts a carriage return in the text at this point. \t inserts a tab in the text at this point. \b inserts a backspace in the text at this point. \f inserts a form feed in the text at this point. Java keywords. A list of Java keywords or reserved words are given below. Abstract. Java abstract keyword is used to declare abstract class. Abstract class can provide the implementation of interface. It can have abstract and non-abstract methods. Boolean. Java Boolean keyword is used to declare a variable as a Boolean type. It can hold true and false values only. Break. Java break keyword is used to break loop or switch statement. It breaks the current flow of the program at specified condition. Byte. Java byte keyword is used to declare a variable that can hold an 8-bit data values. Case. Java case keyword is used to with the switch statements to mark blocks of text. Catch. Java catch keyword is used to catch the exceptions generated by try statements. It must be used after the try block only. Char. Java char keyword is used to declare a variable that can hold unsigned 16-bit Unicode characters. Class. Java class keyword is used to declare a class. Continue. Java continue keyword is used to continue the loop. It continues the current flow of the program and skips the remaining code at the specified condition. Default. Java default keyword is used to specify the default block of code in a switch statement. Do. Java do keyword is used in control statement to declare a loop. It can iterate a part of the program several times. Double. Java double keyword is used to declare a variable that can hold a 64-bit floating point numbers. Else. Java else keyword is used to indicate the alternative branches in an if statement. Enum. Java enum keyword is used to define a fixed set of constants. Enum constructors are always private or default. Extends. Java extends keyword is used to indicate that a class is derived from another class or interface. Final. Java final keyword is used to indicate that a variable holds a constant value. It is applied with a variable. It is used to restrict the user. Finally, Java finally keyword indicates a block of code in a try-catch structure. This block is always executed whether exception is handled or not. Float. Java float keyword is used to declare a variable that can hold a 32-bit floating point number. For. Java for keyword is used to start a for loop. It is used to execute a set of instructions/functions repeatedly when some conditions become true. If the number of iteration is fixed, it is recommended to use for loop. If. Java if keyword tests the condition. It executes the if block if condition is true. Implements. Java implements keyword is used to implement an interface. Import. Java import keyword makes classes and interfaces available and accessible to the current source code. Instanceof. Java instanceof keyword is used to test whether the object is an instance of the specified class or implements an interface. Int. Java int keyword is used to declare a variable that can hold a 32-bit signed integer. Interface. Java interface keyword is used to declare an interface. It can have only abstract methods. Long. Java long keyword is used to declare a variable that can hold a 64-bit integer. Native. Java native keyword is used to specify that a method is implemented in native code using JNI, Java native interface. New. Java new keyword is used to create new objects. Null. Java null keyword is used to indicate that a reference does not refer to anything. It removes the garbage value. Package. Java package keyword is used to declare a Java package that includes the classes. Private. Java private keyword is an access modifier. It is used to indicate that a method or variable may be accessed only in the class in which it is declared. Protected. Java protected keyword is an access modifier. It can be accessible within package and outside the package but through inheritance only. It can't be applied on the class. Public. Java public keyword is an access modifier. It is used to indicate that an item is accessible anywhere. It has the widest scope among all other modifiers. Return. Java return keyword is used to return from a method when its execution is complete. Short. Java short keyword is used to declare a variable that can hold a 16-bit integer. Static. Java static keyword is used to indicate that a variable or method is a class method. The static keyword in Java is used for memory management mainly. Strict. Java strict is used to restrict the floating point calculations to ensure portability. Super. Java super keyword is a reference variable that is used to refer parent class object. It can be used to invoke immediate parent class method. Switch. The Java switch keyword contains a switch statement that executes code based on test value. The switch statement tests the equality of a variable against multiple values. Synchronized. Java synchronized keyword is used to specify the critical sections or methods in multi-threaded code. Java this keyword can be used to refer the current object in a method or constructor. Throw. The Java throw keyword is used to explicitly throw an exception. The throw keyword is mainly used to throw custom exception. It is followed by an instance. Throws. The Java throws keyword is used to declare an exception. Checked exception can be propagated with throws. Transient. Java transient keyword is used in serialization. If you define any data member as transient, it will not be serialized. Try. Java try keyword is used to start a block of code that will be tested for exceptions. The try block must be followed by either catch or finally block. Void. Java void keyword is used to specify that a method does not have a return value. Volatile. Java volatile keyword is used to indicate that a variable may change asynchronously. While. Java while keyword is used to start a while loop. This loop iterates a part of the program several times. If the number of iteration is not fixed, it is recommended to use while loop. Thank you for listening in our discussion. This is the end of our topic about Introduction to Java Programming.